Good day to all the viewers. My name is Bronika Sibin from University Malaysia Sabah. In this video, I will present my research entitled Study on the Preparation of Eggshell Powder as a Partial Semen Replacement in Mortar. For introduction, eggshell is an industrial waste which is commonly disposed in the landfill, but it poses hazard to the public and environment as it may contaminate the soil and water resources. The eggshell is suitable to be used as semen replacement because it has high calcium carbonate content and similar chemical composition to the limestone. Therefore, many researchers have used various methods to prepare the eggshell powder in the structural research and application. For example, air-dried method, oven-dried method, and treating the ESP at high temperature. Despite all the improvement, the preparation method of ESP is not yet established, so the aim of this research is to investigate a suitable method for the preparation of ESP to be used as semen replacement. There are 4 types of preparation method investigated, which is untreated air-dry eggshell powder, untreated oven-dried eggshell powder, treated air-dry eggshell powder, and treated oven-dried eggshell powder. The evaluation method is flowability test, compressive strength test, and hardened density test. This research used type 1 ordinary Portland semen and fine aggregate which is represent obtained from local supplier. It is sieved through 600 micron meter. The eggshell waste used in this research is obtained from QL Agroventure Sendran Berhad. It is then washed to remove the extra debris and then dried by using a dried method or oven dried method. The next day, it is ground and sieved using 75 micron meter and then incinerated into the furnace for 1 hour. This preparation method will produce treated oven-dried, treated air-dried, untreated air-dried, and untreated oven-dried eggshell powder. This is the physical and chemical properties of the eggshell powder. As you can see, the specific gravity, moisture content, and loss of ignition for the treated eggshell is significantly lower compared to the untreated eggshell powder. I only used 20% of eggshell powder to replace the semen and a total samples of 45. The sample size is 50 by 50 by 50 mm cube size. The water to semen ratio of 0.485. Semen to fine aggregate ratio of 1 to 2.75. For the result and discussion of flowability tests, as you can see in the figure, the flow of untreated specimen are higher than the treated specimen and control specimen. This is because the untreated ESP does not excessively absorb water, meanwhile the treated ESP has higher water absorption ability due to the heating process. Meanwhile, the effect of air-dried and oven-dried method was insignificant. For the compressive strength test, as you can see in the figure, the ESP mortar is slightly lower than the control mortar. This is due to this effect of semen dilution because like limestone, the ESP does not possess cementing properties. So there are reduction of cementing materials which result to more free water available to produce small pores and reduce its compressive strength. Next, the treated ESP specimen has higher strength than the untreated ESP specimen. This is due to the extra calcium oxide which improves the strength of the mortar. Furthermore, treating the ESP helped to remove the impurities and organic layers, promoting more reactive reaction. On the other hand, there are significant reduction of strength for the air-dried method compared to the oven-dried method because for the air-dried ESP, it is exposed to the growth of microorganisms and fungus which affect the chemical composition. Also, the contamination from animals and pollution which govern the ability of ESP to react efficiently, and also occurrences of rewetting process which increase the moisture within the eggshell powder. For the rate of strength development, as you can see in the figure, the strength development for all specimens are higher in the early stage, but at the later stage, all specimens shows a comparable rate of strength development. Nevertheless, the rate of strength development for the ESP mortar is still lower than the control mortar. Next, the treated specimen has higher rate of strength development because of its additional calcium oxide, which accelerate the setting time and improve its early strength development. Meanwhile, heating the ESP helps in removing the impurities and organic materials, which increase its effectiveness to react with the semen paste. On the other hand, the hardened density of the ESP mortar is lower than the control mortar. This is probably due to the lower specific gravity of actual powder compared to semen. The lower density of untreated ESP specimens is due to the existence of organic materials and moisture within the actual powder. This causes a formation of more pores and reduces its density. This is also explains the low strength of untreated mortar compared to the treated and control mortar. Conversely, the accelerated hydration process by the treated ESP has created more CSH gel to fill the pores and making the specimens denser and more compact. Next, the hydride specimen has lower density than the oven-dried specimen. This is due to the contamination of ESP during drying process, making them to not react effectively with the semen paste. Therefore, less production of CSH gel to fill the pores. This explains the low compressive strength of a dried specimen than the oven-dried specimen. As for the conclusion for flowability, the untreated ESP specimen has higher flowability than the treated ESP specimen. Meanwhile, the effect between a dried and oven-dried method is insignificant. For the compressive strength, the treated ESP specimen has high strength than the untreated ESP specimen. Meanwhile, the oven-dried method appears to have more impact on the compressive strength. For the rate of strength development, the treated ESP specimen have higher rate of strength development due to the addition of calcium oxide. Meanwhile, the air-dried method causes the lowest rate of strength development due to the contamination of ESP. For the hardened density, the treated ESP specimen show higher density than the untreated ESP specimen. Meanwhile, the air-dried method shows lower density due to the existence of moisture and natural layer. Therefore, it can be concluded that the most suitable preparation method of ESP is the treated oven-dried method, because it shows the most desirable properties compared to the other ESP specimen, such as good flowability, higher compressive strength, and denser structure. This is the acknowledgement for my research. This is the list of reference, and that's all for my presentation. Thank you.